All right, back to coding now. Let's implement the logic that we just spent so long talking about. I'm going to put this logic in a separate class because it's not really related to the fly program. It's just a geometry utility method. So I'm making this new geometry class, and in it I'll add a public static method that will return a double, the angle between 2 points. Those 2 points will be the arguments to this method. So I'll call them from and to. And so in the case of the fly program, from would be the location and to would be the destination. So the first thing to do is to compute delta x and delta y. So delta x is just equal to the difference between the x coordinates of to and from. And likewise, delta y is equal to the difference of the y coordinates of to and from, with the additional caveat that because of Java's weird coordinate system, we want to add a negative sign in front of that delta y. So now we can go ahead and compute the inverse tangent. So our angle A is equal to math.atan. So this is the Java implementation of the inverse tangent. It's called atan because the inverse tangent is sometimes called the arctangent. And we talked about how we can get in trouble here. If delta x is equal to 0, then we'll get a divide by 0 error here. So before we do this, we need to check for that case. So if delta x is equal to 0, we said we can figure out the right value by looking at the sign of delta y. If delta y is greater than 0, then we want to return pi over 2, and the value of pi is stored in this math.pi constant. And otherwise, we want to return 3 pi over 2. Also, another thing here that you may not be aware of is this ternary operator. It looks at this predicate, and if the predicate is true, it returns this first value, and if the predicate is false, it will return this second value. So we've now handled the case that delta x equals 0, so from here on out we know that delta x is not equal to 0, so we're safe to perform this division. All right, so the last thing that we need to do is check which quadrant we're in. If we're in quadrant 1, we're good. If we're in quadrants 2 through 4, we need to do some additional handling on A to get the right value. So let's check if we're in quadrant 2. So quadrant 2 would be, let's see, delta x less than or equal to 0, and at the same time, delta y greater than or equal to 0. So I'll add a comment here indicating that we're in quadrant 2 because it's not immediately obvious from that condition. And so if we're in quadrant 2, what we want to do is take A and add to it math.pi. All right, that's quadrant 2. Let's check quadrant 3. So quadrant 3 would be delta x less than or equal to 0 and delta y less than or equal to 0 as well. So again, I'll add a comment. And in this case, we want to do the same thing. Just add math.pi. And that leaves the final case of being in quadrant 4. So quadrant 4 would be delta x greater than or equal to 0 and delta y less than or equal to 0. And in this case, remember, we just have a negative. We have a negative angle where we want a positive angle. So we're just going to add 2 pi to our angle. So now we've handled all of the special cases, quadrants 1 through 4, and so we can go ahead and return the angle at this point, and it should be a value between 0 and 2 pi and be the correct value between 0 and 2 pi.